Today's video, I'll be talking about various types of M.2 NVMe and M.2 Sata adapters and slots. So there's two types of adapters. The first type is like a enclosure, like what I'm showing here, and the second type of adapter is in PCI-express form. They could be PCI-express like this 3.0 or 4.0 by 4 adapter for a M.2 NVMe, or they could be for a M.2 SATA adapter like this one right here, which you can connect to a SATA slot, I think it's SATA 3 slot in your computer through your motherboard like that. So I'll be talking about the enclosure type. This has much less bandwidth than a M.2 NVMe PCIe adapter, which you saw here. Something like this. So some of these enclosures enable you to use both M.2 NVMe or a M.2 SATA SSD. So this is a M.2 NVMe SATA SSD. You also have just SATA SSDs, and the way you can tell is by looking at the slot or the connectors. So a SATA connector looks like this, as you can see, and an NVMe adapter, NVMe slot looks like this. If I rotate this 90 degrees from right to left, it would be this one right here. This is a M.2 NVMe adapter slot, basically. And you have another type that looks like this. This is the M and B key NVMe slot or connector. So for this adapter, you can use both SATA M.2 and M.2 NVMe. But in other types, you can't do that. Like in this adapter, you can't use a M.2 NVMe like this. This cannot be used, as you can see. An X is on top of that. However, you can use M.2 SATA, which is here. This is okay. This and this, you can use that, but you can't use this. If you connect it, it's not going to work. And as you can see, the maximum bandwidth of these enclosures is about 10 gigabits per second. So 10 gigabits is about 1.25 gigabytes, basically. And this one here is a M.2 NVMe enclosure to be used with only an M.2 NVMe SSD. So as you can see here, an M.2 SATA SSD will not work here. This will not work. This will not work. But however, these NVMe slots, whether they be M or BM key, will work on this adapter. And you have different types of connectors for M.2 NVMe and M.2 SATA enclosures like this. This is a USB-C to USB-C. This connects directly from your M.2 NVMe enclosure to your USB 3.1 or 3.2 USB-C port on your computer, basically. And this one connects from USB-C here to USB-A to a port on your computer. Something like this would be used for something like this, which is an M.2 Sata enclosure. But for an M.2 NVMe SSD enclosure, you could use a USB-C to USB-C cable, or you could use a USB-C to USB-A. You can connect it to a USB 3.1 or a USB 3.2, whether that be Gen 1 or Gen 2, doesn't matter. Should work. This is what you have to keep in mind when you buy one of these enclosures. You can't expect your M.2 NVMe to have the full bandwidth of your M.2 NVMe drive. So this M.2 NVMe drive is, I think, capable of, I don't know, 8.5 or 7.5 gigabytes per second. That's really not possible with an enclosure like this. You're only going to get 1.25 gigabytes per second, even though this M.2 NVMe can handle more bandwidth. You'll be limited by the bandwidth of the enclosure. So that's what you have to keep in mind. And the next thing is you have the M.2 NVMe PCIe 3.0 or 4.0 or 2.0 or whatever, or X4 adapter for M.2 NVMe SSD. So this will only work with an M.2 NVMe SSD. It will not work with an M.2 Sata SSD. You can connect it and try it, and I tried it, and it doesn't work at all. It will not detect it on your computer whatsoever. So as you can see in this motherboard, this is a motherboard that I have on one of my computers. It's the Asus Prime H470M Plus motherboard. M meaning micro ATX, I think. So this computer has two PCI-express 3.0 X16 slots. One on the top, this is for the graphics adapter. This you could use for a second graphics adapter. However, you cannot use 16 lanes on the second PCIe 3.0 X16 adapter. It will only give you a bandwidth of 3.0 by 4 lanes only. You cannot use 16 lanes. On the top, you can use 16 lanes. And here, this is the M.2 NVMe slot on that motherboard. On mine, I have two Western Digital. I think they're N550 500 gigabyte M.2 NVMe SSDs. I have two of them on my motherboard. And you can have a maximum bandwidth of USB 3.0 by 4. And this is the chart that I have for the different types of bandwidth in relation to the generations. The first generation PCIe slot will only enable you to get 250 megabytes per second for one lane. So for 4, 250 times 4 is 1000 megabytes, which is 1 gigabyte. And by 8, 250 megabytes times 8 is 2000 megabytes or 2 gigabytes, and so on and so forth, as you can see in this chart. So as for the 3.0 by 4, theoretically, I will get a bandwidth of 3.94 gigabytes per second. You will not get the entire bandwidth. It will probably be about 80% of that in reality, but in theory, it's about 4 gigabytes. So on this motherboard with my Western Digital N550 M.2 NVMe SSD, I can get the full bandwidth of my M.2 NVMe SSD, which is about 2.4 gigabytes per second, which is 2,400 megabytes per second. That's what I'm able to get in the tests for that. I have another motherboard, which is a Asus H97M Plus. I also have a Asus Z97 Pro. This is in the same generation, so it's pretty much the same. And the PCI-express 3.0 slot, 3.0 by 16 is on the top. On the bottom, I have a 2.0 by 16 rated at only 2.0 by 4. So I will get a maximum bandwidth of 2 gigabytes per second. And I did a test of that on this motherboard. And on my M.2 NVMe that I tested, which was I think it was a Fanxiang S501, which was capable of 1.6 gigabytes per second. I was able to get about 850 megabytes per second because the slot that I have access to is only 2.0 by 4, which fits in this category. About 2 gigabytes, and I said it's roughly about 80%, so I'm getting about 1.6. I also tested my Western Digital N550 on this motherboard as well. The maximum bandwidth is about 2.4 gigabytes per second, sorry. But I was only able to get about 1.6 due to this bandwidth limitation. I couldn't get the full bandwidth of it. Sorry, I didn't test the Fanxiang on this one. I tested it on another motherboard. I was mistaken. It was Western Digital N550 Blue 500 gigabyte SSD, M.2 NVMe SSD on this slot, and I was able to get 1.6 gigabytes per second. That's what I could get only. However, on this slot, this motherboard being the Asus H97M Plus originally did not enable you to use the M.2 NVMe SSD, but you could after you flash the BIOS, which I did make a video on that, and I was able to do that successfully, and I was able to get PCIe M.2 PCIe 2.0 by 4, which I will show you on this computer on Crystal Mark Info, because I have that installed on this computer. Check which drive it is. I'm not really sure. Maybe it's iDrive. This one right here. And it shows here. Sorry, it's C drive. So I'm only able to get PCIe 2.0 by 2 on this motherboard. But the adapter that I have installed is a PCIe. But it's capable transfer. No, the M.2 NVMe slot is only capable of 2.0 by 2. Okay. Let me test that out. Sure. What I really get here. 829 megabytes per second on the read. $762.6 megabytes on the write, as you clearly saw there. Two. Let's see what we get. So PCI-express 2.0 by 2 is 1000 megabytes per second. That's roughly about, so I said I get 80% of that. That's 800 megabytes per second. So that's about what I got here, about 80%. So this motherboard isn't built to use M.2 NVMe. However, when I tested it on my Asus H97M Plus, I'll leave all the videos for this in the video descriptions below. And I'll also put it in the video cards and the end screens as well if you're interested in seeing those videos about the test that I did. So when I tested it in this slot, when I tested this adapter in that slot with a Western Digital N550 blue 500 gigabyte M.2 NVMe adapter, I was able to get about 1.6 gigabytes per second. And this is by 4, 2.0 gigabytes per second. So I was able to get about 80% of that, which was about 1.6 gigabytes per second. So this is faster than that M.2 NVMe slot because it's only capable of M.2 2.0 by 2, as you saw on Crystal Mark. And that's what you have to keep in mind. So if you have an old M.2 Sata SSD, you cannot use it here because this is only routed for PCI-express only. It's not like your motherboard, which can route to a SATA port on your computer. If you wish to use an M.2 SATA SSD, you can do that on a motherboard like this, on a M.2 slot. But you cannot do this with an adapter. So you need to get a special adapter for that if you want to do that. You could buy an M.2 SATA adapter like this. There's many different types of adapters that you can use. And how did I get this information? It's very simple. You just have to look at the manual of your computer. This one here. For the Asus Prime H470M Plus, it shows you exactly what kind of ports you have on your computer. So this is for the M.2 NVMe port. It shows you that it's only capable of PCIe 3.0 by 4 for the first slot and also the second slot. And you can also use an M.2 SATA as well. If you do that, it just uses up a SATA port on your computer. That's basically it. It uses up one of these SATA ports here. And as for the PCIe Express ports, it shows you exactly what you get. Here it is. So you get two PCIe 3.0 X16 slots, but the first one is capable of X16 mode. So if you put an M.2 NVMe in that port, theoretically, you will be able to get 15.76 gigabytes per second on that port. On the second port, you'll only be able to get about 3.94 gigabytes per second. On this port, that is, on this PCI-express port. And it's only X4, even though the slot is 16, you will only be able to use 4 lanes. And as for the two PCIe 3.0 X1 slots there, you only have 1 lane basically for these. So if you bought an adapter that was a PCIe 3.0 X1 adapter, M.2 NVMe adapter, you will be able to get about 985 megabytes per second on this motherboard. That's the maximum bandwidth. So that's what you have to keep in mind when you get an M.2 NVMe SSD. Is you must look at the manual, see what it's capable. This is a more modern motherboard, being an Asus Prime Z690A, and the slots that this has is a PCIe Express 4.0 for the M.2. You're able to get this bandwidth on that motherboard with an M.2 NVMe slot. Well, let's see how much that is on the table. So you'd be able to get about 7.884 gigabytes per second, or 7,884 gigabytes per second with that slot, with the PCIe 4.0 slot on that motherboard. And if you want extras, if you want to put on extra NVMe SSDs, you can, basically. On the PCIe Express port, you can do that. I don't see that on this manual. Let's see. Yes, expansion port. As you can see on the first port, you will be able to get PCIe 5.0 at maximum at 16 slots for the first PCIe X16 slot. For the second one, however, you'll only be able to get 3.0 by 4, so the maximum bandwidth for the second slot will be about 4 gigabytes per second for that motherboard. So that's how you know what to use. So it's advisable not to get a M.2 NVMe drive which has, let's say it has a bandwidth of maybe 7,800 megabytes per second, or 7.8 gigabytes per second. Let's say in my motherboard, which is this one right here. Even though I get something like that, I'm never going to be able to get the full bandwidth, never be able to use the full bandwidth of that on this motherboard. Because at most for the M.2 NVMe slot, I will be getting only 3.0 by 4, which is this. And I'll never get this because my motherboard is incapable of supporting such a bandwidth. So people may say, well, I bought a M.2 NVMe, which is capable of 7.8 gigabytes per second. But I'm not getting that because when I put that into my computer, or slot. Well, you're not getting that because your M.2 NVMe, the computer that it's using, or the motherboard, it doesn't support that, and it doesn't work, physically. It's kind of like having a water pipe. Let's say the water pipe is only able to drain has a water flow of, let's say 1 liter every minute or something, right? But you want a flow of, let's say, 8 liters per minute, right? You're not going to be able to do that with one pipe of water, right? One water pipe. You'll have to have 8 water pipes to drain 8 liters of water in 1 minute, right? That small pipe isn't capable of that, or you'll have to get a bigger, a wider diameter water pipe, which is able to have better water flow. With that small diameter water pipe, you will only be able to drain about 1 liter per minute, basically. So that's how it works. And you also have something called gigatransfers. For PCIe 1, it's 2.5 gigatransfers per second. And what gigatransfer means is giga is a billion and mega is a million. So giga is billions of complete transfer operations per second. This is another way of measuring the bandwidth of PCI-express slots as well. And for 2.0, it's 5. So it's basically double of PCIe 1. And from PCIe 3.0, it goes to 8. And then for every preceding generation, it doubles. So 8, 16, 32, 64, 128 giga transfers per second. If you want to translate this to mega transfer seconds, then this would be 2,500 mega transfers per second, and this would be 5,000 mega transfers per second. This will be, see how much that is. 128,000 mega transfers per second. So in a billion, there is 1,000 million. So that's how it works. In a trillion, there's 1,000 billion. So if they went to a higher, if they one up this, I think after giga, it's pico. I'm not sure. Let me see. Okay, after giga, it's tera. So we would say tera transfers per second. So it would be TT-S being tera, meaning I think that's a trillion. And then after a trillion, I think it's peta. I think that's a quadrillion or something. So this is basically how you could basically buy an M.2 NVMe and get the results that you want. You have to first understand the type of slots there are in a motherboard, in a USB port, basically, and how much that's capable of. And as long as you know that, you will be able to get realistic results. I want to get an M.2 NVMe, which is capable of, who knows? I don't know what kind of speeds they really have. What's the fastest speed? Let me check to see what kind of speed. Got 7,300. So 7.3 gigabytes per second. You got 5 gigabytes per second. Got 7.4 gigabytes per second. So as the bandwidth increases, the more expensive it gets, basically. This is 3.2 gigabytes per second. Okay, 7.4. I could buy this M.2 NVMe, stick it into my motherboard, into this motherboard, and I couldn't use all the bandwidth because this thing's not capable of it. The most this thing is capable of is just that. This. Just about 4 gigabytes per second. That's it. I cannot use all the bandwidth of 7.4 gigabytes. So it would be a waste of money for me to buy something like this, right? It wouldn't be worth it unless I had a motherboard that could actually handle that kind of bandwidth. So that's what I want to share with you today. If you have any thoughts or questions, you could leave it in the comment section below, and thanks for watching.